Assalamu alaikum. Welcome to Calculus1 General review. So let's finish what we started from last time. We're gonna start with this question. Calculate the following limit and derivative. So this is the first question. The second question I think is the derivative. Let's start with the limit. So here they ask me to find out the limit of x sine 1 over x using squeeze theorem. So keep in mind that the squeeze theorem states if I have a function bounded by two other functions, and the limit of those two functions are equal, so therefore the limit of the middle one is the same thing as that limit. That means it goes to the same limit. So here how can I use this concept in this function? So we know that sine function is always between 1 and minus 1. So if I multiply the whole thing by x, so we have minus x is less than x sine 1 over x, which is less than x. So this is my h, this is my g. If I take the limit of minus x when x go to 0, it will give me 0. And if I take the limit of x when x go to 0 is 0. As you see here, both limits go to 0, therefore the limit here go to 0. So limit x sine 1 over x when x go to 0 will be 0. So this will be my answer for this question. Next one, so they asked me to find out the derivative of arc tangent hyperbolic x squared times square root of x squared plus 1. So we don't use arc, we say arg, not arc. It should be arc. Alright, so the derivative of arc tangent is the same thing, the derivative of arc tangent, which is the same thing. So arc tangent of something prime is the derivative of that thing over 1 plus the expression square. For arc tangent hyperbolic of something prime is the same behavior. So we have derivative of the expression, but instead to have plus here we have minus. So that's the idea. So here I'm going to use again x power rule. So if I have f n prime is n f prime f n minus 1, and because this is the product, so I'm going to use product rule. So f g prime, which is f prime g plus f g prime. So those are the three concepts I'm going to use here. So let's start the answer. So arc tangent hyperbolic of x squared times square root of x squared plus 1 prime. So I'm going to apply the product rule first. So it's going to be arc tangent hyperbolic x squared prime times square root of x squared plus 1 plus, so arc tangent hyperbolic of x squared times x squared plus 1 to the power half. I change this one to half prime. So now I apply the product rule. So I'm going to do the derivative of each one by itself. So arc is the derivative of the inside, which is x squared prime over 1 minus x squared squared. So my little square here is x squared times square root of x squared plus 1 plus arc tangent hyperbolic of x squared, and here will be the power rule. So here we'll have half times derivative of x squared plus 1, which is 2x, times x squared plus 1 half minus 1, which is minus half. So now the derivative here is 2x over 1 minus x to the 4 square root of x squared plus 1 plus arc tangent hyperbolic of x squared. Here I simplify this. This is minus, move it down, so it's going to be x over square root of x squared plus 1, and this will be your answer. Next question. So here we have three questions in one question. So here let's start with the first one. So A is about linearization of hx. So keep in mind, linearization is the same thing as the tangent line equations. There's no difference. The only difference is the name. That's it. But the shape is the same. The tangent line is y equal f prime of a times x minus a plus f of a. So this is the equation of the tangent line. So what is linearization? Change y by lx. That's it. So this is the linearization of a function. Now I need to do the linearization of h of x. What I need to do, I need to find out what is h prime of 1, 4 and what is h of 1, 4. So h of 1, 4 is e to the 1, 4 minus 5 over 4. And h prime, so I need to find out what is h prime. H prime is e to the x minus 5, which means that h prime of 1 over 4 will be e to the 1 over 4 minus 5. Now I just substitute this value into my approximation function. So this is, again, it's called approximation function. So Lx is e to the 1, 4 minus 5 times x minus 1, 4 plus h of 1 over 4, which is e to the 1, 4 minus 5 over 4. Now I distribute, so I got Lx is e to the 1, 4 minus 5 times x minus 1 over 4 times e to the 1, 4 minus 5 plus e to the 1, 4 minus 5 over 4. I distribute the minus 1 over 4 here, so I got Lx equal e to the 1, 4 minus 5 x minus 1 over 4 e to the minus 1 over e to the 1 over 4 minus plus 5 over 4 plus e to the 1, 4 minus 5 over 4. So this cancels out. And minus 1 4, we have 1 here, so it's going to be 3 4. So my final answer will be Lx is e to the 1, 4 minus 5 x plus 3 4 e to the 1 4. So this will be my linearization of h of x at a equal 1 over 4. So for question B, here they ask me to find out the untitled derivative, the general untitled derivative. It's like they ask for to integrate this function. So it's the same thing as untitled derivative is the integral of the function. So my function f of x is 1 over 4 times 1 over x plus e to the minus 3x plus 3 minus cosine of x plus 11 x 5 half plus 17 plus 0. So we know that the function that has the derivative 1 over x is ln of x. ln of x prime is 1 over x. So what I do, I need to change each terms by its derivative. So it's going to be 1 over 4 ln of x prime. For here, so we know that e of something prime is a derivative of that thing times e of the same thing. So if I substitute here, I will have e to the minus 3x plus 3 prime. Normally should be the derivative of minus 3x plus 3, which is minus 3 e to the minus 3x plus 3. But here I don't have minus 3, so what I do, I divide by minus 3 both sides. And I put it inside because this is just a constant, it's not going to affect anything. So which means that e to the minus 3 plus 3, in fact, is the derivative of what? Of e to the minus 3x plus 3 over minus 3 prime. So this and this is the same. Now, what is the derivative of function that give me cosine? So the function that has derivative cosine is sine. So I just need to substitute this by sine of x prime. Now for exponent, so the concept of the derivative of exponent is the following. So if I have x to the n prime, in fact is n x n minus 1. Here what do we have? We have 5 half. So here I have n x 5 half. 5 half is in fact is n minus 1. N minus 1 is 5 half. So which means that n will be 7 half. So that means here will be 7 half and here will be 7 half. So here will be x 7 half prime is 7 half times x to the 5 half. Here we don't have any 7 half, so what I do, I multiply both sides by 2 over 7, so we'll have 2 over 7 x 7 half prime, because I put it inside because this is just a constant. The constant can be put inside of the derivative, so keep in mind that f times k prime is just f prime times k. So if the k is a constant, so you can put it as a product of the function and put the derivative for both of them. It's not a big deal. Alright, so here equal to x 5 half, so I'm going to substitute 5 half by this expression, so here will be plus 11 times 2 over 7 x 7 half prime and plus 17, so we'll do here plus 17x plus c, because the derivative of a constant is always 0. So this is what I got for f. Now I can put this, because this is a constant again, I can put it inside. So now my function will be f of x is 1/4, or I can put it this way, 1/4 ln of x. Any constant outside of derivative can put it inside, plus e to the minus 3x plus 3 over minus 3 prime minus sine of x prime plus 22 over 7 ex x to the 7 half prime plus 17x prime, here should be prime, plus c prime. Now what I need to do, I need to put them under 1 prime, so this is going to be f of x equal ln of x over 4 minus e to the minus 3x plus 3 over 3 minus sine x plus 22 over 7 x to the 7 half plus 17x plus c prime. So this is the antiderivative of this function. So my answer will be f of x is ln of x over 4 minus e to the minus 3x plus 3 over 3 minus sine x plus 22 over 7 x to the 7 half plus 17x plus c. So this is how to find the antiderivative if we don't use integration. Alright, so for number C, so let me erase the top bar to get number C. Alright, here for number C they ask me to, the question is f of x equal 4x minus e to the x. We know that by the intermediate value theorem that f of x equals 0 has at least one root. That means at least one root. So this equation's f of x equals 0 has at least one root in the interval 0, 1. So I explained that why f of x has at most one root. So we cannot have at least, but only at most. That means only either one or nothing. So in that case, what I need to do, I need to take the derivative to find out the behavior of the function. Is it increasing or decreasing, or just keep changing the behavior on the interval 0, 1, or it keep only one behavior. If it's keep one behavior, that means it's cross at most. If it's keep changing the behavior on the same interval, that means it has at least. So this is the idea behind. So if I take the derivative, I will have 4 minus e to the x. Now I'm going to find out where the behavior change of f. So I make f prime equal 0. So I got 4 minus e to the x equals 0, which means e to the x equal 4, x equal ln of 4. So in my number line, so this is my 0, this is 1, and ln over 4 is here. So if I choose x equals 0, so this is going to be positive here. If I choose x greater than 1, like for example 2 here, it's going to be negative. So which means that it's increasing, and here is decreasing here. But my concern is not about here, is about that side. So you see, here is increasing on or in the interval 0, 1. That means the behavior of the function, it's monotone on 0, 1. That means is take only one direction, doesn't change the direction on the interval 0, 1. So this is why if at 0 f is negative and 1 is positive, that means it's going to cross to go from 0 to 1, it's going to cross the x-axis only once, because it's increasing, take only one direction, does not change the direction. The function does not change the direction on the interval 0, 1. It takes only one direction. This is why the function has at most one root in the interval 0, 1. So f is increasing function in the interval 0, 1. So therefore f of x equals 0 has at most one root in 0, 1. This is why. If it keeps changing the behavior, or if it's increasing, decreasing, or increasing, decreasing, that means we have more than one. But as long as it has only one behavior, it's just increasing, so it has at most one. Alright, next question. So here they ask me to find out the limit using definition. So but first here they ask me to draw the function. This is just the equation of the lines, so we can draw a line. It's very simple. So when x equal 0, when x equals 0, we have f of x is 4, so 1, 2, 3, 4. When x equal minus 1, so it's minus 1, so it's going to be here. So now my line, so it's going to be this. This is my line. Alright, now let's find out where it's 14. This is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, so it's here. So I'm going to define the neighborhood, so I'm going to assume that this is going to be epsilon, so this will be the distance from here to here is 0.01. So here will be, I will assume that is 14 minus 0.01, and I take the same, this is my 14, I take the same distance here, and I'm going to assume this is going to be my 14 plus 0.01. So my neighborhood, my epsilon neighborhood is here. Alright, so if you want to show this on the graph here, so you just need to draw perpendicular to the graph, and this will be your neighborhood on the graph. This is the absolute neighborhood on the graph. Okay, so this is my 14, to make it clear. Alright, let me write it down clear. So this is 14. Alright, so this is about the graph. So here, for epsilon equals 0.01, find the corresponding delta, such that this statement stay true. So here I need to make sure that I start from here, which is this is my hypothesis, and this is my conclusion. So I'll make sure that I produce my function from here. So I start from here and I create my function here. So in that case I will end up having L here and epsilon, but epsilon in that case will be dependent on delta. That means the delta will be a function of epsilon, not epsilon depend on delta, but delta depend on epsilon. So this is exactly what we'll end up having here. So let me show you the idea. I don't want to keep talking too much. So let's start with this statement. So we have 2 minus delta is less than x is less than 2 plus delta. So I will produce this expression inside here. So I multiply here by 5. So that means I will have 10 minus 5 delta is less than 5x is less than 10 plus 5 delta. Then I want 4, so I'm going to add 4 everywhere. So it's going to be 14 minus 5 delta is less than 5x plus 4, which is less than 14 plus 5 delta. So this is my function. You see, this is my function. This is my limit. So therefore, here is my limit is 14. So therefore, this will be my epsilon. So epsilon will be equal to 5 delta. And we know that epsilon is 0.01 equal 5 delta. So therefore delta, if I divide both sides by 5, will be 0.002. So this will be my delta. As you see, is very simple. I just start with this expression and I create my function inside by using the operation. So here I multiply first by 5, then add 4, and I got my function f of x here. Then I know that 14 is my limit because they say L is equal to 14, so this is my limit. Therefore this bar should be my epsilon. So 5 delta will be my epsilon. So because the epsilon is given to us already, I just need to solve for delta. Now I'm going to use the same concept to prove that the limit of this function is equal to 14 at x equal 2. So in order for me to do that, I need to show that if 2 minus delta is less than x, which is less than 2 plus delta, I need to prove that L, which is 14 minus epsilon, is less than f of x, which is less than 14 plus epsilon. I need to start from this statement and end up here. So, but in that case, what I need to do, I need to use that idea that delta is epsilon over 5. So this is what I'm going to assume at the beginning. So for every epsilon greater than 0, there is delta, which is equal to epsilon over 5 greater than 0, such that, and we start with my hypothesis. So if 2 minus delta is less than x, which is less than 2 plus delta, then I will have, I multiply the whole thing by 5. The same process I did here, I will repeat it again. 10 minus delta is less than 5x, which is less than 10 plus 5 delta. Then I will add 4, so then I will have 14 minus 5 delta is less than 5x plus 4, which is less than 14 plus 5 delta. So I will substitute delta by epsilon over 5, so it's going to be 14 minus 5 times epsilon over 5. This is going to be my function, and this is going to be 14 plus 5 times epsilon over 5. Now I cancel the 5, so I got 14 minus epsilon is less than f of x, which is less than 14 plus epsilon, and this can lead me to this conclusion that if I have this statement, so I can say that limit f of x when x go to 2 is equal to 14. Alright, next question. So consider the function f of x equal implicitly, or defined given implicitly by 2y plus sine x plus y equal to x. So find the equation of the tangent line. So I know that the equation of the tangent line y equal f prime of a times x minus a plus f of a. So here my a is pi over 2, so, and f of a is given to me already, is pi over 2, so y will be f prime of pi over 2 times x minus pi over 2 plus pi over 2, because this is my f of a. Now what's missing is my derivative, so I just need to take derivative here. So we have 2y plus sine x plus y equal to x, so the derivative is going to be 2y prime. Here this is chain rule, so it's going to be x plus y prime cosine of x plus y equal to 2. Derivative here is going to be 2y prime plus 1 plus y prime cosine of x plus y equal to. So from here, if they ask you for a tangent line, don't go further and look for y prime. Substitute right away to make the way how to solve y prime easier. So it's going to be 2y prime plus 1 plus y prime cosine of pi over 2 plus pi over 2, which is pi, and cosine of pi is minus 1, so it's going to be 2y prime plus 1 plus y prime times minus 1 equal to, so 2y prime minus 1 minus y prime equal 2, so this is just y prime, add 1 both sides, y prime will be 3, so my tangent line will be 3 times x minus pi over 2 plus pi over 2, distribute the 3, 3x minus 3 pi over 2 plus pi over 2, so which means that y will be 3 pi over 2 minus pi over 2 is 2 pi over 2, which is pi, so it's going to be 3x minus pi, and this will be my answer. So is it true or false that f of x is always increasing? So in that case I'm going to pick this statement from here. So from here I'm going to answer this question. I'm going to solve for y prime and see if it's always positive or not. So what I do here, I do 2y prime plus 1 plus y prime cosine. Let me put a line here. So cosine of x plus y equal to, so I distribute the cosine, so it's going to be 2y prime plus y prime cosine of x plus y plus cosine of x plus y equal to, take a common factor here and move that cosine on that side, so it's going to be y prime 2 plus cosine of x plus y equal to minus cosine of x plus y. Then I solve for y prime, so it's equal to 2 minus cosine of x plus y over 2 plus cosine of x plus y. So we know that cosine is always less than 1 and greater than minus 1, so it's between minus 1 and 1, so which means that cosine can never reach 2 or above 2, so therefore the numerator is always positive. So here is always positive. Denominator is always positive because the cosine is it's greater than minus 1. Can never be greater than minus 3 or minus 4. Doesn't mean cannot take a number greater than minus 2. So less than minus 2. So in that case, this is always positive, and this is always positive. This is always positive. This is always positive. That means the whole statement is always positive. Therefore, for f of x is increasing for all x. F of x is increasing for all x. So this is true. So let me repeat this. So cosine is between -1 and 1. So if I take only the boundary value, so if I pick cosine equal 1, which is the maximum we can take, I will have this positive. If I pick cosine equal -1, this will be 3, so which means positive. That means both case this is positive. The same thing here. If I pick cosine equal 1, so it's going to be 3. If I pick cosine equal -1 here, it's going to be 1. So in both case, numerator and denominator are always positive. So that means the derivative is always positive. If the derivative is always positive, that means the function is always increasing for every value of x. Alright, next question. So a runner is jogging directly east at a steady rate of 18 feet. So it's jogging east, so that's me going from west to east. A road running perpendicular to the runner path. That's when we have a road perpendicular to the runner path. There is a bear on the road. So we have here the runner x with the speed x prime as 18 feet per second, and here we have a bear. So this is the runner, and here we have a bear, which is y. Let me name it y, and it has a speed 25 feet per second. Alright, so give a diagram. So this is my diagram. Alright, how fast is the distance between the jogger and the bear? The distance between the jogger and the bear is this distance. So this is the distance. I will name it d. Decreasing when the runner is 70 feet away. So this is 17 feet, and this is 40 feet. My y here is 40 and my x is 17. Alright, so I need to find out what is d prime. So we know that this is perpendicular. So therefore I'm going to use Pythagorean Theorem. So I have x squared plus y squared equal d squared. So then take the derivative, because I'm looking for the speed of that path, how fast is decreasing. So it's going to be 2x x prime plus 2y y prime equal 2d d prime. I'm looking for d prime, so I divide both sides by d. So divide both sides by 2d, so the 2 is a common factor, so it's going to be 2 times x prime plus y prime over 2d. Cancel the 2, it will give me d prime. So now d in fact is the square root of this, so it's going to be x prime plus y prime over square root of x squared plus y squared. This will be my d prime. Now I substitute the value into my expression. So I have d prime will be equal to 17 times 18 plus 40 times 25 over the square root of 17 squared plus 40. So when you do the calculation, we end up having 30.05 feet per second, which means that this is decreasing faster. So given the data in part B, does the jogger meet his limits? That is, will the jogger and bear cross path at the intersection of the two roads at the same times? So here, based on the information they give us, it's no. So without even like checking the derivative here, even though it's decreasing faster, but it's not, they're not gonna cross each other. Why? Because look, if at the next second the distance between the intersection and the jogger is 17 and the jogger ran 18 feet a second, that means the next second the jogger will be 1 feet away from the point of intersection. At the same time, the bear, because it's running 25 feet per second, is going to be 15 away from the point of intersection. So it's going to be 15 away from the point of intersection. So therefore, it's, I don't think it's gonna intersect here. So so I don't think so. So it's gonna be 15 away from here, so it's gonna be 15 away, and this one will be 1 feet away from the point of intersection, so it's gonna be on this position, and the pier is still here, so therefore they're not gonna cross path at the intersection. So that means the jogger will be in safe. So that's my comment for this. So you can choose any way to comment this, but this is what I see. Alright, so we're not. So jogger, so this is my conclusion here. So jogger and pier will not cross path at the intersection. Alright, so next question. So the function f of x defined at all x not equal 0 has a second derivative f second. So they give me the second derivative f second is 2x minus 1 over x squared. So first question, determine at which x, if any, f of x has inflection point. So I need to find out where the second derivative equals 0. So this is how to find out the inflection point. So which means that 2x minus 1 over x squared equals 0. So which means 2x equal 1 over x squared, cross multiply, x cubed equal half, which means that x equal cube root of 1/2, and this is where the inflection point, the value, the x value of the inflection point, so is x equal cube root of 1/2. So given that f prime of minus 1 equals 0, find the first derivative. I just need to integrate the f second, so or find out the antiderivative of f second. So f prime will be, in fact, is going to be x squared plus 1 over x plus c. Then I need to use minus 1 to find out the c. So f prime of minus 1 will be here minus 1 squared plus minus 1 plus c, and this is equal to 0. So 1 minus 1 plus c equals 0, therefore c equals 0. So f prime of x will be x squared plus 1 over x. So determine at which x, if any, the function has local maximum, either minimum or maximum. So I need to make this one equal 0. So f prime of x equals 0, so that means we'll have x squared plus 1 over x equals 0. So which means that I will have x cubed plus 1 over x equals 0. So here I can factor this, so this will be x plus 1 times x squared minus x plus 1 over x equals 0. So here that means I will have x plus 1 equals 0, which means that x equal minus 1. So now I'm going to see where we have maximum minimum. So I'm going to my number line. So I have 2 0, so I have the 0 here and the minus 1, so it's going to be a minus 1 and 0, but it's not defined as minus 1. Now I'm going to check the sign. This is always positive, and here just mean I will have positive, negative, positive. So that means increase, decrease, and increase. But this is not part of the domain because it's not part of the domain here. It's given to us that x is not equal 0. So which means that here we have a local maximum at minus 1. So x equal minus 1. So at x equal minus 1, f of x has a local max. Okay, so this is about today. So see you inshallah for the third part. And please, if you have any comment, please do so. It will help me improve my way of presenting those type of questions. And thank you for watching the video, and assalamu alaikum.